last 2 pages of that, there are total graphics problems that relate to the stuff that we're teaching here.
Got it.
Is yes, we in a discussion factor are moving away to take the next step, and we'll do loop by data, which don't compound the graphics with the constructs. So we'll talk about just the constructs, the syntax, and the semantics of that. And
Sounds
then
good.
you can, and knowing this group, you will take me into some far-flung places that I had not planned on. And so we can delve into that, or stick on the just the algorithmic component, and you guys on your own play around with the graphics mesh. So
just interrupt. Can somebody who is not
Charlie
turn off their turn
Oh,
off
it might be me.
yeah.
It's really noisy, Charlie.
Sorry, I'm not at home. I'm down at the beach right now. So hold on a second.
Gee.
I know. It's my fault. I apologize.
not that
Now
much.
that we're all green with jealousy.
Yeah. So yeah, as more and more people going, I think what's going in a way, I'll structure the intro class on the Tuesdays now. Yes, my overall plan, which you guys can trash within a minute and a half, which is fine, that's perfect, is to go into the constructs and deal with some of those algorithms so that we can mesh them with the graphics and get that kind of a solid foundation this week and next week.
Now, Don, you did say I was going to get to show off my really cool program that I made.
You can do that. You can do that anytime you want. We'll pull that off, and you could share that. You did share it. You can do that.
Oh, let's see if I can do that.
Yeah.
We'll share screen 2. Let's see here. And of course, I don't have Python open at all.
Oh, that's sharing mine.
I just lost him.
Did I lose you, some people? Hang on a second. Hopefully this will load fast enough. Yes, I understand that I am screen sharing. That's all well and good, but where is my window? Python, what are you doing to me? There we go. Okay, so if I go to File and I go to Open, here, and I go to Don Files, and there we go. All right, so let me show you this. So should I just go ahead and just talk about what I did? I'm going to run it so you can see it, and then we'll just talk about what I did. Oh, except for, of course, it's showing on here. Here we go. There we go. Phew. Probably should turn the speed up a little bit.
Well, actually, we got it. The picture's there now, so that's okay. Yeah.
I like the colors.
Okay. Yes. So this came out of my husband coming over and looking at, and I was doing just like random colors for each loop, and he's like, could you make it more red? So what I had to do was, you'll notice the R1, B1, and G1 are set to a specific random range. So to create variation, but not excessive variation, I gave the R1 value, the red value, a high value, and the blue and green values a higher range, but a lower value. So a value range. So you'll notice B1 is a random integer between 0 and 120, and so is green. So for each of these loops, it's choosing a different number for red, a different number for blue, and a different number for green, and using that to draw the shape. The other thing that I did is I created the math for, then this is, I didn't put this one in the Google Drive because I was just working on this yesterday, but I came up with the math for the polyangle. And so I can make it work for a number of sides up to around 18, and then things start to fall apart. But I'm coming up with my integer, dividing 360 by the angle change, and that's all well. But I'm creating a polyangle for turning to the left. And so the way that I did that is I did the math of sides minus 2 times 180 divided by the number of sides. But then I had to subtract 180 because the number that comes out is not the interior angle number. Or no, the interior angle number is not the angle that I needed to
over behind each one where landing lives. And,
We ran into this with, I think, a 6-sided.
Yeah, you need exterior angle, not interior.
So then I just subtracted by 180, and then I just made the entire thing negative so that it would make it a positive number. Anyway, there's probably a much better way to do that, but I do like the way that it turned out.
Yeah,
Okay.
this code, Catherine's code is shared on the site. I noticed you put it up there. I don't know if the revisions have been there, but I saw that.
I haven't put the revisions up yet, but I'll throw that up there so you can look at it if you want. Anyway, it was fun.
We're hearing some of these dishes and stuff. I'm not sure who that may be, but yeah, someone may want to think about that. Okay. So, and so the idea is, my present idea is that on Tuesdays, we'll be going over the algorithm, dealing with constructs, dealing with, yes, and also we had some, Johnny had some questions about that. We'll talk about that, and loops, for loops and while loops, and talking about that the next couple times, and figuring out how far we go, whether meshing them with graphics or going independently relative to the problem sets. Then on Wednesdays, starting tomorrow, we will be continuing. We barely introduced lists and stuff on last Wednesday at the end of the thing. We'll start tomorrow going on lists, dealing with that. So some of you that is past where your background has gone, you may want to just get it for to sit back and, you know, kind of go into a zombie state and just let it filter in ideas, or you may just dive into it and get it. We'll be especially talking about this list, I think, one of the most poorly taught structures in data structures in both books and in online stuff. So we'll talk a lot about the pedagogical approaches there. So Wednesdays we'll be listening and see how far we go there. Tuesdays will be dealing with constructs and figuring out how you guys want to play. That's my overall plan. As I said, within 30 seconds, you may take me someplace else and we'll go wherever you go. So that's what we've got there. Any other questions or comments before we kind of dive into dealing with constructs?
I've been working a little bit with the coding and stuff. The hardest thing that I'm having right now when I'm trying to write my own codes is the syntax. Like, I get the ideas and how I want them to execute and the logic behind it. Does anyone have any suggestions on how to learn or teach the syntax?
To me, it's just practice. And that the reality of that is it's just like anything else. The syntax is like learning a foreign language, a very simple foreign language, fortunately, one that can be used to do complicated problems, solve them. But the only way to do that is redundancy, repetitive, doing a whole bunch of problems. So for us as adults, I find the online tutorials fairly decent because they give you a lot of little practice, and we're more focused, and we don't have to be entertained or motivated to do stuff. Hopefully it's more internal. That is what I recommend. And also these problem sets that I gave you, if you want, by looking at them and just coding them out. This is what I picked yesterday. I don't know.
Can I suggest something with the syntax? Not that I'm the queen of syntax or anything, but I am really good at making mistakes. So I feel like I'm qualified to answer this question. Is that what I do is every time I make a syntax error, like when I go from pseudocode to Python or whatever language I'm using, and I'm noticing that I'm making these errors, I have like a mistake journal, like a journal where I collect all my errors and my patterns of errors. And that way, like even when I practice, my practice can be a little bit more mindful. And I also try to figure out why I make the same errors over and over again. That's all I wanted to share.
Jim or Amon, is there some background noise, like a TV going on in the background? Because you're the only ones not muted, and I'm wondering if that distracting noise could be. Okay, it's not Amon.
Sounds like it's Jim, but I think Dawn or Kathy can actually go in and mute them manually.
Yep, there we go. All right. I agree. And matter of fact, the cool part about it is sometimes writing code, not the cool part. As a teacher, I get motivated because I now, every time I write programming, I'm thinking about my students. Every time I like the idea of a journal or whatever approach you use, because everything we do, I can use as a lesson for my student, either to teach in a way that avoids that, right? Is the simpler, the easier, the less frustration we can cause for our students, the more jazzed they are going to be about programming. And two, we can also personalize this, and it makes great test questions, because if we have taught it, we've done it, I now have the problems I'm going to give to them. I'm going to be kicking out this week to you guys about once again, a big collection of output problems, i.e. actual coding that says, it's like the multiple choice test questions that you can get. Here's the problems, tell me what this outputs. Try run this code and tell me. And those will do the same thing. And most of those are generated by doing exactly that. Mistakes students have made or mistakes I've made. Now I make a problem that works on that issue. Let me do it that way. Other questions or ideas before we get diving deep? Or diving into a pool without water, one of the two, depends on your perspective. Yes, Mike.
Can you hear me?
Yeah, a little quiet, but yeah.
Did you, so I found a syntax, basic Python syntax video, but I can't paste the link into the chat window.
Well, why don't you kick it? Oh, okay. One of two things, either kick it to me and then I'll kick it right out to everybody after this. Mike, you can just message me, or whatever way. I don't know why you can't put it there, but if you don't figure it out, since you don't pay any attention to what we're doing here anyway with me, or you don't pay attention to what I'm doing, put it that way. I know Mike well for years. So you can play around with this and figure it out, or kick it to me later and I'll kick it over generically. Anything else? Everybody going to be teaching online in the fall, I assume? Yep, we're all diving right into the fun of that. So I'll talk to a couple individuals, and Kathy and I were already discussing maybe a fall-in service. And so if they're, for OCSTA, if you have stuff that you really kick Kathy an email, the organizational people will, if there's ways we can help. I know T is doing some stuff relative to that. It's one of his workshops. So let us know, and people who have that knowledge can play around with that. I may talk to a couple individuals about unique opportunity maybe, and we'll see just how it works for you guys. So anything for the good of the order before we kick in?
Don, I have a question about Thorny. Have you heard of it? Do you recommend it? Or does anybody have anything to say about that interface?
Once again, what was it? I missed the first part.
Thorny, Thony or Thonny. How easy is it to use with kids as an interface to run Python?
No, I have not. Is anybody?
I've used it a tiny bit because it's on Raspberry Pi and it's not too bad. But I really like Trinket.io, and that's the one that we're going with on my school district. So
I used Trinket and it was pretty straightforward. Yeah, I do it in West Albany, and they seemed to grab onto it real quickly, and there was no issues relative. And we were doing really minimal amount of interaction, and they got it. So
yeah, the neat thing about Thony though is that the shell and the screen where it's running, they're in the same window, so they're not moving back and forth between windows and things. And it's also on the it comes pre-installed on Raspberry Pi too. But I mean, each has their own. From when I've played around, each has their own features, and you just have to decide which one you like the best.
Does it have an automatic attachment to Turtle Graphics? I know some of the stuff that Mike came up with, you ended up having to tweak it a little bit to make that linkage. You might test that. That's the only issue that I.
Yeah,
if you're
I'll
choosing
test it.
this way.
I'll test it afterwards. I mean, because I've got it up right now, but obviously typing's a little slow, so we're not going to be testing it at the moment.
Yeah.
But yeah.
And
Actually,
Tim's
let me
picking
give.
out some stuff, yeah.
I'll go test for a second. I'm going to pull in one of your programs and stuff. I'll be back.
Yeah, so that's the only thing. It just depends on your approach. You need to make sure that Turtle Graphics links into the IDE and/or figure out how to do that. Yes, that's the issue. Okay. All right. I think what we'll do. Oh, you got it there, Micah. Yeah, I don't know what happened there. Okay, what I'd like to do today is with all of this, and we've jumped into it in a way already. Several of you have either individually code or we did it as a group with for loops and everything else. To backtrack, like I said, if you are doing Python just as either for an elementary sort of structure or middle school just for a shorter term, or even high school for one of the 9-week block exploratory type programs. If you're doing that, then you can pull off using just what we have done so far, dealing with Turtle Graphics as generic sort of format and doing what we have done with expansions. So with kids, it takes more time. I know with the computer club group that I did at middle school, where we have gone, we spent with them, 10, 12 weeks getting to that stage, because them doing it hands-on, doing all the codes and everything else. So how much we've done in 2 weeks took them, a lot longer because they explored it. We did a lot of side stuff and everything else too. So that can take care of that. But if you're wanting to do a full-blown semester course, or you want to go further and you have more details, then we need to start interjecting some of the organizational and discipline and other syntaxes in a way that correlate. And the way to do that, to me personally, is to, once again, one bite of banana, step outside and only solve little teeny problems relative to these constructs, so they get both, as it's alluded to already, the syntax, as well as the appropriate use of this tool. Because a sledgehammer, you can build a bookcase with a sledgehammer, but it ain't going to look very good. And it's going to take longer and all the other issues.
Aw,
So
but the challenge.
well, you can use your arm now. You can just use
Yeah,
your
fung
back.
sung. Just to back up, yes, Thonny works with Turtle, no problem.
Oh, good.
Just ran it.
So what, if you're going to do that, I'm going to backtrack with ourselves and deal with that content and put it in context and deal with those sorts of components and questions. And we can slide off the side as we're doing it. And that's where Ranjani's stuff last week about dealing with if then else, and if sequencing, when do we choose which and how and why, is part of that same sort of puzzle. So if we do this and go to, whoops, backtrack here. I'm going to kick back to the whiteboard here. I think you guys have me there. With constructs, the construct just means a tool, a building block tool, structure. So what you've got is, on the constructs, there's 3 categories: linear, looping, and decision. Now, is this coming across fairly clear to you guys? I see my picture, but it's hard for me to see you. I want to be
Don,
out of
it's
the way
beautiful.
just to focus on this. So that's good.
Working great.
All right,
Good job.
good. Thank you. So when you've got this linear construct, is just that you solve a piece of a puzzle and just go down the way, and just pieces of and as I alluded to in the earlier conversation, if you look at the intermediate help sheet, we have all the mathematical tools and all the components there and some other stuff too, but that's all you're doing. And we'll look at some problems. You want to enter you want to enter 2 points in the distance between those 2 points. You want to do simple averaging of 3 scores, so you get score, and average it, and show the answer. Those are the type things. And real soon, students realize that no, there's no point to a computer if that's what you're doing. We are faster than the computer, than writing the code and doing that stuff, unless the mathematics is elaborate and this does it. And that's what your calculator does. That's most calculator stuff. That's what you're doing, is you're doing a linear program, no matter how elaborate the structure is. That's kind of going on, although we can code them way beyond that. Now on looping, we had two choices. One is, we have known and unknown number of times we're going to loop. Now, but the key is when a kid looks at a problem, for me, what the idea is that they need to know what tool to pick up and why to pick up the tool. So when do I pick up looping at all? When do we choose? When I read a problem and say, aha, I need a loop here. Now, you might say, well, duh, but no. In our audience, see, that's the problem. I don't know about you guys, but in my class, any course I taught, there was probably a fourth of the students who really didn't need me, right? All they needed me to do was introduce a couple ideas or point them to something, and then they were on their own. That was just what it was. Now, matter of fact, my goal for them was to teach them whole other things, like working with groups and helping others and we have a whole lot of things to teach them, but relative to the curriculum, core curriculum, they had it. But then there's the 3/4 of the rest of the class, and 30 to 50% of them, they have not really learned, and we have done a pretty sucky job in many ways of teaching them how to learn, how to organize their thoughts, how to do that sort of stuff. And therefore they get frustrated. They think they're crappy at something, when in reality, it's interesting. In computer science, huge numbers of the jobs are not working for Google or Intel or Microsoft, or they're not working for that. You're not at a job where you have to work like crazy and be at a very high level of thought process on a regular basis. I'll be honest, and there's nothing wrong with these. They're working for the state. They're working for a small business to do stuff. And the cool thing, they have radically good things about that. They work from 8 to 5. That they don't want them to work overtime. Therefore, you solve simple problems and you do stuff. And that's a phenomenal family living wage job for a huge number of our kids, depending upon where you're working. Therefore, those kids, we need them. They can't find them. I was just talking to Kathy before this. Districts are already talking to them to try to find out they're hiring. T and Kathy and I were talking there. They're hiring people to teach more stuff what we're doing, trying to, and they can't find them. And what's really weird, they're also trying to find substitutes already. They're looking for long-term substitutes because they know things are going to happen. And good luck finding a long-term sub relative to it. I mean, think about it, what you guys are trying to figure out, and then you're going to get a sub to do that? That's insane. So we don't need just the top echelon and creative, all this new wacko, beautiful stuff. We need people to maintain stuff and do stuff. So getting people showing our average students how to do this and how to have fun doing this, and that they feel competent at doing this. We need them, and they get family living wage jobs, which are fantastic. So showing these types of stuff may seem a little crazy for you, or it may be perfect for you, but we need to do that for the population in our class. And I don't think textbooks and stuff do that. We don't show them how to learn, how to remember. I love the idea of the journal. The kids doing that exact same sort of stuff may work perfect for them. So we've got the two loops, known and unknown number, correct? Everybody feel comfortable with that after our earlier discussions and stuff like that? Several of you, the problem is some of you had Wednesday and some of you only had Tuesdays, and so we're going back and forth. So that's it. So when I read a problem, do I know how many times, or do I not know how many times? Okay. No number is easy. What do I do? What tool do I pick up?
That would
For
be the
blank.
4.
Yeah, the
for
for
loop. Okay. And what ends up happening, it may be relative to syntax. Every time you write this, some of you, I just write it short and sweet for. But you may want a slightly bigger piece of banana and just write out the standard tool, the standard construct that for loop works like, right? For variable and range. You might want to just kind of do that every single time you're doing it that redundant. What my students I called it power notes. And it's actually, I know most of you are not dumb enough like I was to have to take graduate work and have to do comps. So, but I chose one and then all of a sudden went, oh, I have to take a test at the end of this after I was into it for 2 or 3 years. On myself, that's exactly what I did. As soon as the paper got out, as soon as I got that exam, I spent a whole bunch of stuff doing my math, my master's mathematics. I wrote a whole bunch of garbage. The first 15 minutes had nothing to do with looking at questions. I just wrote down on top of the test paper all that short-term memory garbage that I had on the top of my sheet of paper. Then in the middle of question 15, which I would have forgotten by that time, I could look back up the top of the page and doing that. Second, just by writing it, I didn't need 9/10 of it because as soon as I did it, it reinforced those. But those little tricks that all of us have, and you guys might either independently use those or have, we need to impart that information onto our students because they don't know how to do this stuff. They really don't, for whatever reason it may be. All right, so think about that. So here, that's a power note. You've got that syntax, you write it down on the top of the paper before you even take your quiz. Therefore, you've got it by the time you get to that question, the syntax. Unknown number. There
While.
Pardon? Yeah, while loop.
While.
In Python, the only choice we have is the while loop, but we have 2 versions of the while loop.
Natural and artificial.
Because of, yeah, they were natural flag versus artificial flag or whatever jargon you chose to use. Now, by the way, pick out a problem. Give me a problem and fix this. Everybody else, by the way, if we're doing this today, you need to be stopping and asking along the way. If this is, I'm seeing like 5 faces. Everybody else is blanked out. I have no problem with that. But I'm looking at what I'm seeing here. And the couple faces are either they're interacting verbally or I'm seeing and they're going, okay, I think I got it. That's what I'm reading from these little small pictures I got here. So you need to interact and say, ho, 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 backtrack a little bit, or let's move faster. I tend to, if I'm not getting any questions, I tend to say, let's move quicker because I don't want to bore you guys. There's tons of information, let's move it. So I'm going to do that unless you stop me. Okay? So therefore, verbalize someone, pick out, give me a problem, make up a problem that has to do with an artificial flag. You can look through the sheet. I mean, in reality, I gave you like 12, 13, 14 pages worth. I can't remember what the final version was after I edited it. I gave you a whole bunch of problems dealing with looping, structure. Pick one of those out. You can even talk about it by number or just make up something. An unknown number, artificial flag.
Enter grades and -1 when you want to stop.
Okay, enter grades and do whatever. Find max, min, average, whatever, any statistical thing. There we go.
Okay, I've got one. Let's say you have an event, you invite, I don't know, 500 people, but you want to enter how many people actually showed up, and you wouldn't know that. So when you enter that, when you're done entering, as the person comes into the event, you enter their number, and then you have an artificial flag to say, okay, the door's closed now.
There you go. Okay. They have a ticket or an invite or whatever else it does that. Perfect. Other options? Okay, or everybody feel comfortable with that? So,
yep.
So what does the syntax of and or the pseudocode, because we can go 2 different levels, we kind of combine them. What is the algorithm or pseudocode for an artificial flag always look like? That's a beauty. It always comes out to be this way. And we developed that last week a little bit, and we can ask questions about it. So what does it look like? That's called a question.
It could be while name is greater than, or well, number is greater than 0.
Okay, now careful. and it's just our verbalization, and we've crammed this together so much with the time. What I'm asking for is the generic algorithm that would work with all artificial flag while loops. So what I want is the pattern that I can take any problem you give me and stuff into this thing. That's what I want, the algorithm here. So be careful, make sure you don't stub your toe along the way, but we can actually take whatever we got and test it. If this was a real classroom, that's exactly what I would be doing. I told you I love taking exactly what my students give me and doing it and then going, ha, 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 let's tweak this. Can anybody figure out what's wrong with
So
it?
Don, so the generic one would be while condition is true.
So
Well, first you have to
while
pick the flag.
something, okay, and if this sucker is true, that condition in there,
Yeah, but first you got to get the flag, or otherwise the thing won't know what the
there you
condition
go,
is.
right? In generic terms, this is what we've got to get to. Before I get to that condition, I have to have the value that I'm checking, right? You talked about the people entering with their tickets for our dinner, or Mike's was getting a student's grade. I have to get that before I walk into this loop to set that up. So above this, and you can use whatever jargon you want. Is that still on the screen? It's hard for me to see.
Yeah.
A little too, is good? All right. So I'm going to get the flag. What I just call it is the flag variable, meaning the variable that is going to hold the thing that I quit. And what I use that as a construction site, and I say, all right, so what we have is what flag am I going to wave in the air to say we be done? So in Mike's example, it would be a grade.
When you say get, do you mean initialize?
Nope. In this case, I mean literally, because in this situation, what kicked us out of the loop, Redani, in yours, it was the invite number, correct? And Mike's, it was a grade. I had to literally from the user or from a file, but right now we're just dealing with user. From the user, I have to obtain a value. So when I say get, I literally mean input.
Yeah, that's why I was wondering why you used get instead of input, Don.
Okay, you can do that. The reason we have done this well, let me back up. You can use any jargon you want that makes sense for you. You're right. And that's why this is a pattern that is my pattern. In my students, we started way back at the beginning with dealing with linear constructs. And so on. If I'm teaching my kids, the word get made a whole lot more sense to them than even input relative, especially girls and stuff like that. My diversity in my classroom, the word input brought along with it some other, oddly enough, kind of negative sort of internal stuff. They never use the word input on their normal day-to-day vocabulary. It just never happened. So I really, for me, it made a difference. That's what I'm saying. So you do whatever works for you and your population. That's why I use get. Okay. And we actually talked about flag variable a lot of time early on. We said this was a flag. When we did the for loop, we said, when do we quit? When we got to the end. That was the flag that said we were done. We do it 10 times. Here, in this case, I don't know how many times. Therefore, what variable am I going to use to kick me out? And that's what condition was. My flag variable, sometimes we built this up. We would literally say, while my flag variable doesn't equal the flag. And the flag, we talked about all this jargon with the kids. This is what my kids came up with. Like I said, twist this to your own vocabulary, your own personality. To me, it was a flag like a construction site. Here's a flag that says you stop. All right. So what is the variable at the top? Mike said -1. But Johnny, I don't know who you specified, but whatever value you're going to use to kick us out of this loop. All right. Now, by the way, would I be introducing it this way right now? No, we talked about this last week some, so I'm kind of skipping ahead a little bit relative to the introduction to it for the students. We would be doing a whole lot of problems in developing this, but we're taking it from there. So I give my flag variable. In Mike's case, it would be grade. In Johnny's case, it would be invite number, whatever it was. Yeah, Mike.
Well, I just want to, I mean, you used to always differentiate between pseudocode and full syntax code. Because right now you're communicating in sort of modified English rather than in code, just to get the ideas on the board.
And also if we do this right, one of the key things I said about instruction effective relative to what Mike Dunlap and several professors said, whatever I teach now is got to go down the line for when I teach the next language, and it should make it radically easier. And if I use Python syntax here, I'm teaching Python, and that's not what I'm trying to do at this stage. I'm teaching them how to solve a problem, how to think. And it so happens that this exact algorithm will work in Fortran, C++, C, Python, Java, processing. It'll work in any of those languages, and that's what I want them to get down. This has got to be internalized. Therefore, any piece of new syntax you throw on, they learn it in 2 minutes. What a fascinating thing is our oldest son, when he went, his background was Java and C++ and C and all the other stuff after he graduated. His first job, they were a C# shop. He had never looked at C# before in his life. But within 6 weeks, he was leading workshops on how to solve the problems within his group, within his entire agency, because he had all the foundational stuff. All they had done is memorize syntax for C#, and all of a sudden they were given problems, and Isaac was saying, they're solving these, Dad, like in the craziest ways, because they just have memorized syntax to their student, and they're doing it insanely inefficient. And my boss came to me one day, I was working on stuff and sent some stuff, and he said, Isaac, this is great, what's going on, why? And he said, oh, that's because, and he started spewing out pseudocode to him. And the boss went, oh, this makes sense, I'd never heard it that way before. So yes, like Mike's saying, I think that's insanely important to give them the foundations, and the language is like the easiest part. Okay, so get flag variable while our flag variable doesn't equal our flag, then what?
Do stuff.
There we go. Yeah, we got somebody that got down from the other day. We do stuff. Whatever our stuff is. If it's counting it up, like our invites, our people who came to a restaurant, I mean, to our dinner, so I don't pay for any more than people showed up. Or if it's Mike's average, I would have to do a couple different stuffs within Mike's thing to take care of the stuff. I have to take care of it. Then what? And here's the part that students screw up constantly. And we can talk through this if we don't have it today.
Do we want to put an if statement outside the while loop to capture what we'll do in case the flag variable gets flagged, I guess?
You could use to do it two ways. The fact is, like we alluded to in the past about examples where they may not have any data at all, so I need to trap the zero so we don't divide by zero or other issues. We can do that. In all honesty, at this stage, I would recommend not. That's another bite of banana that I don't want them to be thinking about. I want them to focus on this bite of banana, because the fact comes up to be is we're not finished it yet. And yet, after correcting thousands of AP exams, there are huge percentages of students who don't understand this. And I'm talking about the majority. They do because they just do what the textbooks tell them, and the textbooks never tell them how to organize this. Because we're not finished this piece here, actually. If
you have to, Don, you have to have some way to end that while loop. And so you have to make a change to the, or you have to test to see if one of the conditions has changed the flag. So you have to do some kind of a test inside that while loop to.
Okay, well, let's do it. We're going to take what you guys are saying. I like this. This is good because we'll develop it. I think we had some other conversations. So one of the ways, one of the key people, one thing that students do is they'll now test this. They'll do if what. So we'll do some test. And we'll talk about this in a second. And then, well, how do we do this? Let's do a concrete, let's do Mike's example. Okay, let's do Mike's example about doing an average. So we'll do real specific. You guys keep that note down. I have to pull this. So we're going to get, what is going to be our flag variable on, I want to get an unknown number of scores and output the average. That's the problem. So what is my variable? So I'm going to say I want to get scores. I want to get a score.
Well, if the flag is a negative number,
Okay.
then it's a while loop. While
Yep.
score is greater than 0.
And I'll put syntax here. You don't need to. I'm just putting it here just to review, and you can do that with the kids. I don't require this of them. Matter of fact, I give problems at the beginning of the quizzes and tests that say they can just write it out. They get the same amount of points whether they write pseudocode or code at first, because that's the outline we got here. Now what?
You need to start a count.
Number of scores and output the average score.
Count plus 1. Well, you probably need to set the variable, but you need to do a count.
I need to count up how many. Why do I need to do that relative? We didn't have to do this. If I said input 100 scores and output the average score, I would not need to count.
Correct, but since it's an artificial flag, you need to count up how many entries you're going to have.
Because
it's unknown.
there we go. Nobody knows how many. In order to calculate the average, I have to divide by the count. So I got to do it myself because we don't know what it is. All right. Then what else?
Increment the score, the sum or score or whatever.
Okay. So I now have sum, or since we said that, sum, and I'm just pseudocoding, so I'm not writing code at all. Sum plus the score. Right? We need to add up the scores there, right? So I'm summing up the scores. Okay. Now, Charlie, we were saying something about trapping this. And by the way, this is what this is great. This is exactly what you'll see. So we would have to say what?
I'd be able to answer that question if I understood what we were trying to do in that if loop.
In that if decision? Yeah, so Charlie, can you explain that one a little bit more, what you were worried about or what we need to deal with? Yeah.
Yeah, I don't think we need the if, Don.
I'm just going along with what you guys are telling me, so here we go.
So if the goal is to find the average, then would have to come out of the while loop and set up a formula for the average, right?
Yep. So, okay, we come out of the while loop. And yes, I am purposefully doing strange things right now, but so we figure out the average. The average would equal
Sum divided by count.
Divided by count, correct? Good. Does this solve the problem?
Wait a minute here, though, just a second. I want to interject a tiny bit here is I do have students who score 0.
Yep.
There are students that I fail, but that would still go into an average. So if while score is, yeah, so we've got to have something. Yeah, thank you. I do have those students who earn that.
Well, no, we have to. So our flag is -1. So we can say, well, our score doesn't equal -1. That's the way we do that syntactically, all right?
Well, why wouldn't you say greater than -1?
Oh, you could say greater than -1. Either one of those work. One of the reasons I kind of like interjecting this not equal to is multiple pieces. One is when we get to strings, when we start using strings as for our exiting, like type in a name and a bunch of information, the not equal to, there's some playing games we play with that, but this is cool. So you're saying you want to have it, well, what?
Greater than. Yep. I have one more question. Are we at all concerned about typing? Like,
no, remember this is pseudocode. Right now we're not even doing any code. This is not supposed to be thinking about that. We're trying to come up with the algorithm for while loops, because what ends up happening, and it was blatantly obvious when you correct a mass amount of tests, students were reinventing the wheel every problem they came to. They had to look at it and solve it and think and do all this garbage, and I don't want to have that. A good carpenter doesn't have to look at the toolbox and say, which hammer do I pick up this time, and let me sit and spend 15 minutes doing that. No, they know which hammer to pick up, and they're automatic. It just innately does that. We are carpenters of these problems. Therefore, I've got to be able to pick up a tool and use it. And you, at this moment, which is cool because you're just learning, and your students, we need to teach them what the tool looks like. What does it always look like? And right now we went to a concrete example to build this, because right now we got a problem.
So Don, there is one thing we haven't done yet.
What's that?
We haven't outputted or printed anything. There's nothing.
Yep, but once again, we'll show have. Good.
But the other thing we haven't done yet is we have not, inside the loop, we need to get the score again to continue.
Why?
Because you got it the first time, and if you don't get it again, it'll never change. And so if it was valid the first time, it will be an endless loop and never end.
There we go. Matter of fact, this is one of the output questions that is given on every one of the random multiple choice tests. Does everybody see what was said? If we dry run this, that's what I talk about as a sample. If we try this out, we'll get a score. So I say, cool, get a score. We get 80. While score is greater than 1, -1, it is. Count is count plus 1, so count now becomes 1. We're not worrying about initializing. We're just getting the pattern down here right now. We'll get to the rest later. Then we do sum equals sum plus score. So sum is 80. We hit the end of our loop, it goes right back, and it says, well, score is greater than -1. Well, score is greater than -1. So it becomes 2, 160, 3, 240, and we have an endless loop. We'll never get to our purple stuff to do anything display because we weren't there. That's because we used a hammer that didn't have a hammer head on it. We got one nail started and that was it. So what did we need to do for the code to work? We needed to get the score inside the loop, correct? Well, I'm going to be devil's advocate. I'm going to say, well, this was stupid then. Yes, I should have done get the score here. That will solve the problem. It does, kind of, most of the time, kind of. It's a lot less the head shaking than it really is here. Because if I did the following now, I initialized, I know those things. Kirkwood always gets me on those. I got all that. Will this work?
No, because it's going to assume the first score is 0.
Yeah, but that, oh, so?
Which is not
but that's greater than -1, that's cool.
Right, but it's not an entered score. It's just setting the variable.
I get the score, but I get a score before I do my math. So let's check it. Let's see. Good. So what do we got? We got score is 0. We got count is 0. And we got sum is 0. While score is greater than -1. It is. Get a score. Cool. I got 80. Count is count plus 1. Sum equals sum plus score. This looks good to me. We'll get the next score. It goes back and a score greater than -1. Yeah, it's 80. Give me the next score, 60. Count 1 up to 2. This got it. Oh, this is perfect. No, it worked. This program's working great.
Except.
Oh, really?
Except when you get to the point where you've entered -1, that gets included in your
so we need
total.
To test this. But can you see your students doing exactly what we just did? And that is they do a couple and they think they did great because they're actually listening to you compared to the one who just wrote the code down and typed it in. They're doing, but we need to go all the way through the entire process. Exactly right. So the last time my score to kick out, I type in -1. And guess what? Count goes up by 1. Sum goes down by 1. And it will now kick out of the loop, but will by average be correct? And the answer is no. So how do I solve that problem? Ah, shoot.
What? So wait, why would it run the loop if the score was less than -1. Would it not do that? Because
No, but
that wasn't true.
So let's check this out again. Watch carefully. That's very, very important, what we're just doing right now. So we started here. We didn't have a score. It was 0, right? We got in the loop. Let's just run our exact example. Get a score. We got 80. The count went up. Sum went up. It went through the loop. What is it using to check for a score greater than -1 right now? It's using this 80, correct? So we go in. It's cool. We're good. What are you talking about, Kirkwood? That sounds great to me. So we get another score. We got 60. Count went up to 2, and sum went up to 140. Perfect. It went back up here. Scores greater than -1. It is. So we get the next score. We want to quit. They type in -1, but it automatically goes down here, and now our count is back to 1. I mean, a count is 3. It went up by 1, but our sum went drop down. Instead of 140, it is now 139. And it went back up, and now score is not greater than -1, so it kicks out and prints our average of 139 divided by 3,
So
rather than 140 divided by 2.
So the problem is happening because we're checking for that condition, well, with our prior score. So how about we nest an if-else statement inside the while statement?
Now, by the way, what we're doing right now is the exact conversation I have with my students. This is exactly what we do. This is how to teach it. It seems, and Mike did it. Mike, right? I mean, Mike and I ended up working together for years, and this is exactly what almost every classroom does. As a matter of fact, if they don't, and there's a bunch of answers coming off, I kind of almost nudge it over to this discussion. So how do we solve that? You would do what? I love it. We don't want to use that -1, correct? So what did we do? We said if, in our case, if score is greater than -1, then we're going to.
But
I meant to say that you get the score after the if statement.
Oh.
Like while score is greater than -1, if score is greater than -1, then you can bother with getting the new score, incrementing the counter, changing the sum.
Ooh, I love this. This one's a different version than I thought. So good. Let's test this. Let's put it right inside. Now, by the way, what we are doing, and I gave the example before of doing geometry, teaching an entire chapter on triangles with the kids rather than the proofs in the book. That's what we are doing. When we finish this entire conversation, this is going to be their process, not one that I handed to them, but they're going to understand all the pieces of this puzzle. Plus, this thought process is exactly what I wanted to do when we're doing very radically more elaborate high-level thinking relative to coding. So let's check it out. We get a score. Well, no, our score was 0, our count was 0, and our sum was 0. So let's walk in. Score greater than -1? Yep. The score greater than -1? Yep. Get a score 80. Count is 1. Sum is 80. It's here, goes back up. The score greater than -1? Yep, it is. I go in. The score greater than -1? Yep, it is. Count, get score. I got 60. Count equals count plus 1. Score is score. By the way, this is what we call hands-on. These are the codes that I will hand to you this week, that I have a whole multiple sheets of this, where the kids have to practice this for quizzes or worksheets or everything else. So now, we counted, we added it up, we hit end. It goes back up here. Is score greater than -1? Yes, it is. Is score greater than -1? Yes, it is. We get a score. -1. We want to quit.
Okay, I see the problem. You want to do what?
You see, good. You see the problem. That's exactly what I want the students to do, isn't it? That's what we want to have happen. We don't want to tell them what the problem is. They see it. That's perfect. Because now we're back to the exact same place, aren't we? We now all do this. So that was a great idea, but it didn't quite work. So what was the problem? Getting the score inside there lets us do the -1 incremented in ways that we don't want to have happen, correct?
Well, Don, you know what's interesting about that is it gives me this key that if I see an if statement that's asking for the same thing directly after a while loop that's asking for the same thing, those are just repeating the same action twice. So I don't want that ever.
Exactly right. It is, if we set this up right, that's the conversation I want to have the kids say, hold it, even when we verbalize this was sounding really redundant because that was checking it and this is checking it. And that just seems kind of crazy. There's got to be a better way. And there is. But the fact, because that's what the issue with this, by the way, this works. This works. It doesn't work well because of what we just said. We doubled every single time we do this loop. We're checking for score greater than -1 twice. That just seems radically inefficient. Is there a better way? And the answer to that question is yes. And that answer works always for an artificial flag. And that's what we're developing here. You see, now what we're doing, the conversation we're having here is exactly the way we would teach it in the classroom setting, I think. Okay. And so what will we do? That was redundant. That while and the if was redundant. But if we had just the get score in here, it added it to this garbage. And if we moved it around in here, it could add it, or it was redundant and both, or both. So what is the solution to this problem is one that is not blatantly obvious, in all honesty. It really isn't.
Don't we want to put the get score outside of the loop?
Yep. And so we say, aha, maybe the get score should be here. But then we come back to our original problem, which was we have an endless loop, right? It seems like that, but no, what's really weird is we do need to get the score again inside the loop, but we don't want that flag to be incorporated in our counter and our summation. So therefore, it doesn't seem obvious. And what's interesting, guys, I've taught this for 40 years, multiple periods in a day, in a year, and yet almost to the word, what you guys have done is exactly the conversation that everybody thinks of. And no one thinks about this one at all because it is not, it doesn't seem like the natural flow. But do you see how this solves the problem? I don't need an if because here we go. Okay, up here we would do some equals 0. We get a score, 80. The score greater than -1? Yep. Counts 1, sum 80. Get another score, 60. The score greater than -1? Yep. Count is 2, sum is 140. Get a score, -1. Is it greater than -1? Nope. Kick out. Aha. Have is 140 divided by 2, turn out 70. Everybody see that? So that's literally, this is the conversation. Yeah, we're done.
I guess the goal was to try and get the score and check the score immediately after. And that's what this has accomplished.
Exactly right. And whatever way you want to have the kids verbalize that, that's what I always say to the kids. Think, you know, never copy what I give you. This is either my old man style or it is somebody else in the classroom. Now, by the way, if that works for you, fantastic. But if not, use your own jargon. Use your own. Pseudocode is your communication tool. I like the journal idea of we're making mistakes and that's what we're developing it. So how do I generalize this? Now that we have this, let's generalize it and we will take a whole bunch of examples and say, does this work? So how do I generalize this process for our algorithm? That's what computer science really is. Every tool we build is an algorithm. And we had several. We had a counter here, count equals count plus 1. That's an algorithm. We had tote sum equals sum plus score. That's a summation algorithm. We have a whole bunch of little teeny tools that if we practice them enough, they become innate. And that's what they have to be. I can't be a basketball player or a softball player and have to think about, oh yes, now I should be moving in front, pick and roll. No, they're scoring the basket before you figure it out. It's got to become fluid. So what is the pseudocode for all
How about
artificial
this?
flags?
While condition.
Before a while.
Before a while, okay. I don't know. Set
Because,
variables.
and it's a shame I had to erase this. It'd be better if we had a whiteboard and you were seeing it. If you wrote down what we had, I'm going to give it to you and we'll set this up. Get the flag variable.
Don, we need to refocus the camera.
Does it come back on its own? It's got to.
Great.
Is it coming in or not?
So the reason I didn't say get flag variable is because I was keeping it even more general. This is how I kind of see your algorithm. I say, while condition, do process, collect input, and then outside the loop, report solution.
But in Rajani, notice that if we use that level of pseudocode, we have missed our whole discussion was about this piece of the puzzle. Our whole conversation we just had was getting to this point. Is it more focused now or not?
Yeah, it is.
Okay.
You got it.
Do you see? This is what those red lines of code are what our last 20 minutes of conversation were about. Because it was not natural for any of us at the very beginning to do it that way. And yet, that way was the solution to every one of our problems. Avoiding redundancy, avoiding math mistakes, avoiding all of those pieces of the puzzle, that was a cure. Therefore, in all honesty, I believe that is the most important part of this. So it's not making this too specific, it is making it the generic tool. Every single time I do this problem for an unknown number artificial flag, this will work. That's the coolest thing. As a matter of fact, we can expand condition depending on what you want to do with your kids. In all honesty, for generic approach, meaning it always works. I don't care if this is C, Pascal, processing, Java, C++, Python, it will always work that you check that piece of pseudocode with no syntax in it will always work.
Now, Don, do you still also need it to export something? Like you need the program to do something at the end?
But see, all that is another algorithm. Do you see my point? Everything you're talking about is another piece of the puzzle. This is this piece of puzzle. Because it depends. Where Johnny could say, I need to pay, the caterer $100 per person who comes to the wedding. So therefore, I count up how many at the end I have to do count times 100 equals cost equals count times 100. Mike, to do the average, we had to do all this other. So if anything, you could say do stuff out here. You could put that there, but in reality, that is not part of the algorithm. The algorithm is how do I get an unknown number of items? I don't know, I don't care what I'm doing with them right now. One bite of banana says, get that stuff in. The do stuff will change no matter whatever problem I'm doing. Does that make sense?
Yes.
And what's weird is, what's kind of cool is that you guys, coming from a whole different background, a whole different style, by the way, every workshop I do this, it comes up to me the same way. Where we do that get flag was the stumbling block. was when we stubbed our toes. And so if they get this algorithm down right there for getting an unknown number of items, that always works. Always. I don't care what the problem's about. It could be figuring out the total payroll for my company. It could be figuring out what my stock is at the end of the day. It could be, it makes no difference. That works. Does that make sense? Other questions? Now, by the way, what I really want to stress here, if you guys, especially those of you who are out coding or have coded in other languages, or if you looked at tutorials, has that, what we just had, that conversation we just had, does that occur in any textbook or any other place that you have seen? Online tutorial or anything else? They either just hand you something or, and frequently it's wrong, it's not helpful, and I can tell you because I see the results. And that's the beauty of, the only beauty of correcting that many stupid tests is that you see the results of what education has done. That, and by the way, can you see the bigger picture here? What we have just done with one of the simplest algorithms we're ever going to face has prepped us, both our classroom and us personally, for radically more challenging stuff in the future. And for every step along the way, they have now seen how they can go through and test and check things out to verify what's going on. Michael.
I just wanted to say that when you taught me this, and because you taught me programming so I could pitch in, when you taught me this made me realize that I applied this to my Cisco stuff. I taught networking. I applied this to Cisco commands for Cisco networking equipment, but also my math classes. You know how how we teach, how words mean math operations. And I'm telling you something, when you just talk about it in English and you get your ideas out, then actually writing it in, say, algebra, it actually makes it really easy for the kids. So this is a really valuable thing, I think.
Don, could we talk about if we can apply this to a situation with natural flags?
Oh, good. That's the next sequence. Next sequence of events would be say, okay, hold it. Now, so you see what's going on. That's why I 100% agree. What I want a kid to be able to do is I want them to be able to read my problem and then say, what tool do I use to attack this problem? I don't know about you guys, but I made huge mistakes beginning my teaching career. I made huge other mistakes later in my teaching career, but in the very beginning, one of the things that we always did was we would teach a section, I'd think about math, right? I would teach this type of problem, and then I would give them a little quiz or worksheet on it, and they would ace it. That was cool. Then I would teach them the next little unit, and they would do the problem, and they would solve it, and they would ace the quiz or the worksheet, the homework, perfect. Then I would give them, so by the end, I would have like 3 or 4 little components. And then I gave them a quiz or a test that covered them all. And guess what happened with a good 50% of my students? They fried because they knew how to solve A when I gave them A. And all the problems that dealt with A were there. Then I taught them B, and all the problems were with B. But when I gave them A, B, C, and D, they look at the problem and they wouldn't have any way to delineate between, well, how do I solve this problem? Tomorrow when we deal with in lists, that is one of my huge examples relative to the screw up that textbooks do and online tutorials do with lists. Because there's radically different ways to use them, and yet they never are taught. We just throw them into the pool and say swim, and I'll come back in an hour. If you're still swimming, then you're part of the computer science group. If you drowned, well, you didn't have it anyway. No, I didn't have it because I didn't teach you how to swim. It's my fault, not yours. So this is the same thing. So we're Johnny perfect. I now give problems, and so what I would do is I'd give a bunch of problems that are just artificial flags unknown and natural, for loops. So I would give them several problems and we would verbalize that. And they would go, oh, this is that one, and we'd do some codes. And then what would I do? Evilly, I would then come up with, say, okay, cool. Now roll the dice until you get 2 7s in a row. Roll a pair of dice until you get 2 7s in a row. Right? Now, does everybody see, is that a for loop? No, backtrack, I'm sorry. Is that a loop? Do I need a loop in the first place? Yep. Because I don't know, I'm gonna roll the dice a bunch of times. So even if they started it, by the way, you go, well, duh, you airhead, no one will ever do. No, you have no idea. Like I said, in reality, what you have to do is, even if you don't ever plan to do the AP test, of course, even if you're in middle school, I 100% agree with everything. I have no problem with no one ever taking an AP exam ever again. I have no issue with that. But you ought to go and look at the College Board website and just look at the problems. Because kids will solve problems without loops. And this is an AP test, and they'll do like 6 statements. And they're all redundant, and they lose huge points because it's unbelievable. So that first question, is this a loop, is not blatantly obvious to everyone. And we need to set that up. So is it a loop? Yes. Now, what type of loop? This. Is the rolling the dice a for loop? Because?
I hope not.
No, although I've seen it with the stupid exit condition, which is crap code, and I take points left and right and tell them why. But anyway.
It's a natural flag.
Okay, because it's not a for loop and it's not an artificial flag, because why? Now, what do we mean by natural flag?
It's going to naturally occur at some point.
Yes. I don't see, as an English teacher, I never allow to use pronouns in my classroom. Sorry. So, because I don't know what an it looks like. And so you write it, you do that. It's crappy writing, but I do it also. My kids, I love it when I say those statements and I reinforce it. Then guess what? Of course, what will happen in the very next sentence I mentioned in class, I will have an it on it, and I'll have 4 students diving down my throats and smiling the whole time. I love it. So that's perfect.
The condition will be met automatically over the course of the problem.
Right. And so in this case, what was our condition, or what was our flag?
7.
7. And that 7 was given to me in the problem, and it will happen without me, the user, having to do anything specific. The computer program itself will come up with that some point in time. That is what I call a natural flag. You can use whatever jargon you want. Okay? So we have that sort of structure. Everybody see that? So now, does this pseudocode work for a natural flag? And you could say, well, let's look at it. If the 7, so here we go. Our flag variable in this problem, let me kick back the screen, sorry.
Interesting, Don. I think the audio is coming from the camera by the bulletin board, not from the audio on your computer.
Was it clear when I'm over here?
It is.
That's interesting. I'll have to check that out. I thought I had that set. Well, look, is it still fuzzy when I'm over there?
It's a little wonky sometimes.
Okay. I'll triple check that. I thought I had, it just maybe this mic is way better than that mic. And maybe I'll switch cameras. I'll do something here. I'll figure that out next time. Sorry.
Yeah, it kind of sounds like you're talking in a tunnel when you're by your computer, but when you're by the board, it comes through amazing.
That's this camera's better than that one. So maybe the mic is better. I'll switch it and see if, even though I'm sitting there, if this mic still picks me up better. That may be, even though it's behind me. We'll see. Thanks. I'll check that out. Is it good enough for me to continue, or do you want me to tweak it right now?
Continue.
Oh.
Okay. Okay. All right. So well, since I'm here, we'll do it anyway. But let me know later on. It'll take a couple seconds, but I can get it. Thank you for those things, but I can't tell those. What I'm doing with Kathy, it's perfect, but that's just one person, and who knows with all the other issues. So would this work? So our flag variable, or the flag we're using is a 7. That's the thing that says stop, right? The 7 was the thing that told me to quit. Our flag variable then, what was a 7 going to be? That would be like roll, right? So we get roll. If we just did this pseudocode, we'd get roll. So they'd roll a dice. So our specific one would be roll, and they type, it comes out to be a 9. Is our flag variable roll equal to 7? Nope. It would go in and do stuff, and in our case, right, we're counting up how many rolls it took me to get whatever. I don't care. Or the sum of the things, I don't give a rip what it's doing. Then we would get another one. So I'd roll the dice and I'd get a 7. It'd go back up here. Is it a 7? It'd kick out. Okay, we now hold it. Let's change our do stuff to the simplest possibility. I'm going to go roll plus 1. I want to just tell me how many rolls it takes to get a 7. Does this work? Does this algorithm for an artificial flag work for a natural flag? Would this print out? It print out 2 for our rolls. It's pseudocode.
Your roll is off by 1.
Yep, we got an O box.
So initialize your roll to 1 at the before the first
could.
get flag variable.
We could, that's one cure at this point in time. But in the future, if we did a whole bunch of stuff, we might have to initialize and think about Fibonacci sequence. When I have 2 numbers, I have to play this game, and I have to. So I'm going to have to think before I solve this problem. Every single time, I'm going to have to figure out how do I initialize my values, correct? And I have to think about that before I do my loop. So it adds to the pile if that's what I'm going to choose to do, right? I'm going to choose to do that. I would have to do some initialization up here. I have to always think about that in my algorithm. And that would work, but is there a cleaner way to pull this off? And in this case, there kind of is. And that's why I'll be honest with you, I really like other languages that actually have a do loop or a repeat until loop because they work easier. They're cleaner. The syntax fits perfectly. This one, we have to tweak it. And I don't like it as well because we don't have that other loop option. But what we end up discovering, and I'm not going to take the time today unless you guys want to, if we just put, since we know we got to go into our loop once, that's the other way artificial flag, natural flag is. Natural flag, or think about it. If I had an unknown number of grades, or even the wedding party, one option is that no one took the test, or no one shows up. So I could have nobody ever in the loop. But if I'm going to roll the dice until I get a 7, what is true?
You're going to roll it at least once.
Yep, I got to go in my loop at least one time. That is that's a big difference. Some students use that I got to use a loop at least once, and that's the definition of this type of natural flag. The only problem is most students' brains, anytime you read a problem, you automatically think we got to do this at least once, otherwise why this idiot make us do the problem in the first place? So therefore, that I found for many students isn't enough to separate, to delineate between natural and artificial flags. Hence, that's why I came up with natural and artificial, because it was something different. But if we do this, it ends up just doing the following. We just get the flag variable inside. Up here, we init. And yes, I agree with you, Johnny. I think you can play the game in what you just verbalized and justify that algorithm for this. It's just that it will not generalize to other languages where this does. That's why I find it a weakness. I think Python, by not giving us this construct, they've taken away a potential solution that is easier.
So Don, I had a question.
Yep.
If you roll a 7 the first time,
correct,
in this concept, and the goal is to get a count of how many rolls
yep.
you had to do, my concern is, wouldn't the while loop be kicked out initially and the count would end up at 0?
No, because where did you pick up, when I say get flag variable, in this case, how did we get our flag variable?
Oh, we got it in the loop.
And
so our
how
count
did
would
we
be
do
1.
that? How did we get our flag? Did we get it from the user?
No, we probably did a random random integer range.
So I did the random jump to get the dice, correct? Therefore, getting is here. If I initialize these all to 0, which is the stand, the good thing about this is multiple initialization is almost always we set things to 0. Our brains tend to work that way better.
That makes sense.
This generalizes to other languages, other programming languages radically better. In C++, it's do while. You just plug this exact same thing, replace the construct with that one, it works. With Pascal, it was repeat until. And every one of them, therefore this algorithm, all I do is replace the stupid syntax of Python, that one, and put the other piece of syntax in here, and it's 100% the same thought process. That's one reason why I teach it this way. So here we just do count plus 1, correct? So everything's 0.
Yep.
So it's not equal to the flag, which was 7. We roll the dice and count it up. If it was 7, it would kick out and say our count was 1. If it was a 9, it would count it up 1, kick back again. Is it 7? Nope. Roll it again. 12. Is it? We count it again. It's 2 rolls. Is it 7? Nope. Roll it again. It's a 7. Aha. Count it again. That's 3. Was it a 7? Yep. Kick out. We print 3.
Check. Got it.
So, Ranjani, I think you're right. If all you're doing is doing Python and it's more comfortable for you, there'd be one less kind of algorithm, except you're still going to have to deal with initialization differently. But you could justify that other answer. I completely agree. Just kind of tweaking the one algorithm.
So, but in both examples, there's one thing we learned, which is that in this example, we had to make sure that we counted immediately after getting the flag variable to make sure our count was accurate. And in the last one, we had to make sure that we checked the condition right after getting the flag variable. So order is something that really mattered in both cases.
Yep. And I agree with you, and I think that verbalization still separates between artificial and natural flag or whatever, however you want to, with your kids and with your way to explain things. But what I would recommend insanely highly is just take this honking big sheet of stuff that I call Python homework that I gave you, that whole, and literally look through all the loop structures, and in your brain just automatically go for loop, no number, yep, done, check, 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 unknown number, is this, and whatever algorithm you choose in your head, go through the pseudocode relative to that so that you test to see if your algorithm is consistent, that it works for all the kids. That's one reason why, and I'm sure there's still typos and everything else. I revised it again after I gave it to you guys initially. I came back and revised because like an airhead, I'd never been that organized. So this is like on 20 different documents I had throughout my folder, different places, and I compiled them all, trying to put them there. I'll keep adding to this, and if you find new ones, please let me know. I would love to add to this pile of problems and then have it that way. But I would check your algorithm against all the problems to make sure it works consistently. That one of these 3 choices work. For loop, natural, artificial, whatever you choose to do. Makes sense? Now, is the sound okay here, or is it still the echoey thing now since I'm sitting here? Is it okay? Oh, decent. I may tweak check that next before.
Yeah, it's a little quiet, Don.
Okay, well, I was trying to talk more quietly. I'll talk a little bit louder here. It must be back mine. That's never been, Mike, my students always say that constantly. Mr. Kirkwood, you're so quiet. So yeah, here we go. Yeah.
It just seemed obvious when you stood up and walked back towards the camera that your voice got louder and louder.
Okay. Okay. All right. Now, any other questions about the looping structures? What it will take is more practice and just redundancy of stuff. And first of all, like I said, I would not even look at code. I would just sit and literally go through all those problems, picking out loops, writing pseudocode. And then you'll discover that, as Mike alluded to, writing a code is the easiest part of the puzzle. You already have it solved. You already know what you're going to do. So the syntax is the easiest piece. Yep. Now, if you had, I printed out another sheet called, and you have this thing, the if else if, else if, elif worksheet talking about that. What we've got is on our constructs, and by the way, the sequencing here, I'll be honest with you, my sequencing of, I always do linear constructs first, that just is. But then frequently I will take whatever the students ask and whatever questions come out, and either do decisions, if and if else's, or jump into loops quicker. If I'm doing the graphics stuff, turtle graphics, it is natural to do the loops sooner than the if then, because the loops come right away into doing what we're going to do graphically. So the questions that they come up with are coming from the graphics, and that's why the looping comes right away. I have done it completely different. I will have 2 classes in the same year, the same day, and I will be teaching the looping to one group, and I'll be teaching decisions to the other group because the questions they asked. And now, if I was you at first, no, I would just set it up and go for it and have it organized. But after a couple of years, you'll get that rhythm down, you can do it. All right, so under decision constructs, what we have is, we have just the if, or we have an if else, or we have an if elif, and then it can end up with an else if that's what we've got. And so what we tend to do is, one of the ways to get this, and when Johnny asked me real specific questions for it, I liked, this is one of the ways that I think students get the hang of this more quickly than anything, and then you can use your own jargon. I use dependent, independent, that you can use depending on where your kids are coming from or what you like. You can change that completely. A decision just says I'm coming along and I have to choose one thing or another. And by the way, later on, if you look at that note, I talk about efficiency and we'll deal with that issue. So if I want to know, I've got an unknown number of students and they're inputting their, or I've got 100 students and they're inputting their credits in a whole bunch of domains, and then I want to know if they graduate or not. Well, then I've got to decide which of these it works. Now, if I say graduate or not, notice those are dependent. They either, if they graduate, then they don't not graduate, right? And sometimes students see these letters here. If I just do a series of ifs, what are the possible outputs if I have a series of ifs? And just assume these letters A and B are like a print A, print B. So if I just have the ifs, if it was just this section 1, what are the possible outputs if I have section 1? If that's print A, print B inside there.
Well, wouldn't they just represent an individual decision point? So if X is 7, do this. If X is 5, do this. But there's
Correct.
no like, if X is 4, 3, 2, 1, negative.
And matter of fact, those are why they're independent. It's 5 and 7 are 2 independent beasts. Actually, they are dependent. We'll talk about that in a second. But anyway, in another way. But here what I'm saying is this. I'll explain it on this one, maybe it'll clarify. If I'm running this code, and that's a print A and print B, when I run this example, I could have nothing show up. It could be that A nor B showed up. Why?
If neither of those conditions were met, then neither A nor B would show up.
So if that condition was met, it prints A. If that condition's met, it prints B. But if either one of them was there, it would not do it. What is another possible? So I could have, by the way, this is exactly a great multiple choice test question. Tell me what are the possibilities here, or tell me which of these cannot occur. Both of those are a great one, although I don't like negative in my test questions. But here we go. So one possible output from section 1 would be nothing. What's another possible output from section 1?
One thing could happen or 2 things could happen.
Okay, so we could have an A just by itself, or we could have a B just by itself, or as some you just alluded to, we could have both A and B. Does everybody see that? So those are the 4 possibilities for that sort of a sequence. And everybody understand the logic of why all of those four possibilities could occur? Any questions?
Could we give an example? Because that would make it clear. I'm not exactly sure how, how you've numbered it as 1, 2, 3. Am I supposed to see 1 as one example and 2 as a second example and 3 as a third one?
Yes, these are 3 different algorithms that come. One is a series of ifs, another is a series, an if-else sequence, and the other is a sequence of if, elif, else. So those are 3 tools, right? That if I have a problem, the kid needs to pick up the right syntax. So on one, what it mean is if these are completely independent decisions. Example was, yeah, print out, tell me how many, I'm gonna roll a dice 100 times. Tell me how many 7s occur, and tell me how many odd numbers occur.
So that would be like saying if it's a 7, and then if it's an odd.
There we go. Because could I, and we'll talk about the other ones, frequently, when we do some thought processes, when we look at other possibilities, clarity comes, right? When we just look at one, it's a little fuzzy, but when we see other options, and oh, now I see why that one's different than this one. We'll check that out, okay? And that's what we do. So exactly right, they're independent. A 7 and an odd, or an even, whatever we choose, are independent. I gotta count them in both places, so they don't depend on each other, okay? Okay, and you can use your own jargon, whatever that may be, to separate that thought process. Whereas, and we'll talk about variations on this theme a bit, if I ask to roll a dice 100 times and tell me how many odds and how many evens occurred, or better yet, roll the dice. Oh no, I better just stick with that. If I said, tell me how many odds and how many evens occurred, don't worry about efficiency right now. Just keep thinking about these algorithms. Would 2 ifs be necessary? Would I check if it is even, count, if it is odd, count? By the way, would that work? Yeah, it would work, but where you shake your head, no, why not?
No, did you say me? No, I thought it would work. The if could work, but the if else seems like a better choice.
Why? Good.
Well, because if it's not odd, then it's even.
They are dependent, right? Yeah.
I suppose.
And so what would the benefit be of doing an if else? You're 100% right. But there's actually a benefit, an asset there.
Charlie, something's going on with your mic.
Yeah. Now I don't get it.
Yeah.
It's still not discernible.
Yeah. Oh, sorry. Yeah. Okay. So what else? Why is an if else? What else about that construct is better in this situation?
I don't know that it's better in this situation.
Sorry, Kat. I mean, I know it looks nicer and all that, but that's not the reason for me to choose an if else. No. The only benefit I see is that something will most definitely be printed when you run the program, as opposed to an if and an if, because like either it's odd or even, or something nonsensical is also included in the else, right?
Yep.
In that situation, did we have to put in an artificial flag? And I'm wondering what that might happen.
Yeah,
what might
happen?
I'm
not worried about the looping structure at all. I don't care about what's going on there. All I'm doing is this one do stuff right now. So the artificial flag, I don't give a rip about that. Okay. So what we've got is this. There is a benefit in the sense that what does the computer have to do in this situation?
It has to check for both conditions.
Therefore,
whereas for if, it just has to check, or for the second one, it only has to check for the first. And then if it's not, it doesn't have to check for the second.
And checking takes time. checking takes time. And I want my program to be as efficient as possible. So I want to pick up the best tool, not a tool that works, but I want to pick up the best tool. Therefore, this one has to check multiple times. This one, and we're going to talk about efficiency even more so in a bit with a series of these. This one only checks there, and if it's not there, it all traps in there. But Johnny's also right. This one, every possible answer fits into one of the categories. Whereas in category instead one, no, there could be a whole bunch of things that don't fit into either one of those categories. Okay, so those are the two. Does everybody see that? Therefore, when I'm picking one of these tools, so far it looks like I have a couple questions to ask myself. For Johnny, that's what. How do I delineate between these choices? One of the questions is does everything get trapped? Does everything impact something? Do I count everything? And the answer to that is yes. What tool must I use?
There must be an else, and there must be case checking facility. I don't know if cases are a thing in Python.
No, unfortunately, yeah, or unfortunately, depending on your perspective, no. Yeah, but you have to check everything, and the last sieve is an else which traps whatever's left over. Exactly right.
Well, somehow this must be a problem with my education, but I don't know, does 0 have, is it a negative number? I mean, does it have a state like that? Because it's nothing. So could you get a false positive from that second decision?
But we're talking about inside our loop. So if we're talking about rolling the dice, there's no such thing as a 0 or negative number within our realm. We're saying within the problem set that we're working on, does every possible value, every input value have to be dealt with? Or some things I don't give a rip. They don't matter.
I just didn't understand that we are making that decision. That makes sense.
Okay, good, yeah. All right, so we asked too, when we read a problem, now we have a loop around it, right? This is in the do stuff part. This is in the do stuff part. I could roll the dice 100 times, that's why I know I got a for loop, and now I'm going to do stuff with those 100 dice. Or it could be a natural flag that I'm rolling dice until I get a 7, but I could be doing stuff with those 7s someplace. Okay? Everybody follow that. So now I need to ask 2 questions. Number 1, does everything have to be dealt with? Do I have to do something with every possible value? And 2, are they dependent or independent? Do they matter on each other? If one of them is there, then they're out. Because the last choice is like the combo, the morphing. We have an if, elif. If we have a sequence, that's your case that you're talking about, Johnny. If I have that structure, I have an if, elif, elif, else. And it goes through the whole sequence of events.
What if there's a case within a case? So like, did you roll an odd number? And then if you did you roll a 7? And then if you did you do a combo of this and this?
Good. What we do is we can embed, every one of these constructs can be embedded inside of any other construct. So what we do is, first bite of banana is taking care of the broad scope. Then we say, like just as you were saying, maybe we said, I want to know the number of 7s we have, and then I want to know whether it was, if it was an even number, I wanted to know how many even numbers less than 6 occurred, or how or above 6 occurred. So I want to keep those counts. And we're doing pretty wacko things here, and we'll talk about some more practical ones in a bit. Now, how can I organize that? There's several ways to do this, by the way. So here, we repeat the problem. I want to know how many 7s occurred, and I want to know how many evens below 6 or below, and how many evens above 6 occurred. So now think about it a second. There's several approaches to this problem. We'll talk about, is there a better one?
What do you mean by evens above 6?
We're rolling 2 die. right? So I'm going back, I'm sorry, I didn't preface it. So even totals, so 2, 4, and 6, or 8, 10, and 12. Okay, is that clear? Sometimes I get jumping ahead.
Yeah, we probably should put at the top something like for a problem surrounding 2d6 rolled.
Yeah. So I want to know if it's a 7 or if it's even, if it's 2, 4, 6, or 8, 10, and 12.
When you say it, do you mean is one of the number cubes 2, 4, 6, or is the combo, is the sum? Okay.
Well, and I'm sorry, and once again, this is what we're rushing. We're doing it. All my students know since day 2, when I do random stuff right away, I tell them every problem, anytime I mention dice, I'm talking about normal dice, a pair of normal dice, 2 through, so you get the sum of 2 through 12. I'm talking about that, unless I specify otherwise.
Do you have dice and make them roll them to understand?
Matter of fact, what's cool is, we talk about that. Matter of fact, I allow on a test kids to have styrofoam or little foam dice with them to sit on their desk to do their little hands-on with. And yes, we have played this game a whole lot to talk about what real probability, we alluded to that the other day. I think it was in the Tuesday class about having one dice with 2 through 12 on it versus 2 dice with 1 through 6 on it each. So we talk about the difference in probability relative to that, whether it works. So we've already dealt with those issues in training.
No, you're talking about even and odd, like it's one thing to check for, but like, can you use or, if roll equals 2, 4, 2 or 4 or 6 or 8, or like, it's more complicated than just saying if roll equals even, right? Even's not a.
Good. 2 things. Your answer to your question is yes. And if you look at the sheets or the other stuff there, we talked about the conditions of syntax on their if then else sheets. I got a wrong camera here. This little sheet here that I printed out for you today, or gave to you. The if, else if, blah, blah, blah. What it does is there's syntax for inequalities. It's to test for equality, it's going to be equal, but it's a Boolean check, not an assignment. Or greater than, less than or equal, greater than or equal, not equal is exclamation point equal. And then the next thing, it can be combined with ors or ands. Exactly right. Disjunctive, conjunctive phrases are completely legitimate. Now, by the way, we've also talked about this earlier on. You could do this in a very horrendous way. To check for even, what could we do? Exactly right, going for what we would just so let's do this right now. We could say if tote equals 7, and I'm actually doing syntax to get that in here, we count 7 plus 1, right? We add 1 to the 7s. Okay, I'll just change this so I don't have to write so much. Num7 plus 1. Num7 equals num7 plus 1. Okay? Now, what could I put next? I could put either another if, or I could put an else. Correct? Now, by the way, that's different, because if I'm talking about counting evens, what could I do here most effectively?
Elif.
Yep.
Mod.
Everybody see that? Why would an else be better, and an elif is what we're going to use? Why would that be better than an if? If I'm counting even totals.
So you don't have to do the process again and again?
And if it's a 7, it's not going to be included in this piece of the puzzle, is it?
No, it's not.
I'm asking you to count evens. If I was asking you to count odds, I want to know how many 7s, and then I also want to know if it was odd numbers between 1 and 3 or 5 and 11, then could this be an else?
I think else would only work if it is necessarily a non-7 number.
Right? What is it? Where we said 2 questions. Are they independent from each other? can they be separated? And if it's sevens and evens, yeah, those are independent. You can't be both. It can't be a mixture. But if I said I want to do sevens and then I want to do something with odd rolls, those are not independent. They're part of the same beast, or they could potentially be, right? If else is only used, its versions are only used if they're completely independent. And does this take time? Yeah, and you're seeing what we're talking about. That's why we have to develop and practice and do this stuff with a whole mess of problems. But syntactically, and yes, it was this, since these are independent, in Python, it is elif. Now, what was just given was what could we do to get an even?
Could we do tot mod 2?
Oh, good, good. Yeah, there we go. CC, you were talking about doing, we could say if tot equals 2, or tot equals 4, or tot equals 6, or tot equal, and that would work. But as soon as I got doing this, what should be big yellow lights flashing in my head?
How to simplify it.
Yeah, it's got to be easier. There's got to be something easier than this, because this is too much work for me. I'm too lazy for this. So I go back to smart and lazy, and yes, one of the things, and once again, our pace is, and oh my Lord, okay, our pace is radically different than a classroom setting. But when we did linear equations, I would have dealt with a whole bunch of stuff with evens and odds and multiples of 3 and multiples of 5, and how do we do these things to make it easier on ourselves. And what is the definition of even?
It's divisible by 2.
There we go. And divisible by 2 means what?
There's no remainder.
When I divide by 2, there's no remainder. And what operation in coding gives me remainders?
Float.
No, float does decimals and stuff. That's a typecasting. That's float and int.
Mod.
Mod does that. And we made that a target. I don't know if we talked about, matter of fact, I'm pretty sure it was on the Wednesday class when I did Euclid's algorithm, Euclidean algorithm for finding the greatest common factor. That's where this popped up the first time. But mod is an insane, mod and div, I told you guys that other class said, it's insane how often, if I've got something that is really kind of tweaky, I can do it in my head just instantaneously, but I can't figure out how the computer to do. Guess what? Mod shows its ugly face. It's insane how many times that works. And in this case, it's example 2 or 4 or 6. That's stupid. I got to do better, but how do I do it? And it is that. Yes, if tot mod 2 equals 0. This even means divisibility by 2. Multiple of 5 means multiplicity by 5, and so forth and so on. Correct? Now this is one way. This is you're telling me we're gonna write out two. Remember, I say we want solutions, and we don't negate solutions so that we get them out and say, do they work? Yep, this works. This is cool. This does that. Now, is there another solution? Is it better? Is it more efficient? Once we get out solutions, we compare. And we don't trash solutions before we even got them out. So this looks like it's working so well. How would I deal with the next part? And this comes from Johnny's question earlier on. What did I want to know? I wanted to know if it was even. I want to know whether it was 2, 4, 6 or 8, 10, or 12. So what can I do now?
Else.
Okay. Now careful. If I put an else here, what have we done? This is great. This is perfect. By the way, it makes a great multiple choice test question or a quiz question or a discussion question. If I did this, and this is when we practice it. With an else, what are the possible outcomes?
It all depends on how you're generating tot. If tot is something the user's giving you, then you can complain in the else section.
But remember, we're talking about a random roll. We're talking about 2 regular lines.
Okay, so if we're using like rand or something like that, do we want to report anything to the user if we end up rolling any?
How many 7s occurred, And I want to know how many 2 through 6 and how many 8 through 12s occurred.
In that case, maybe you don't need an else.
Matter of fact, don't need is a weaker word than I think we need to have here. Matter of fact, do I want an else? Or what did we use an else? When we're trapping everything, every possible response has a result. And when I'm rolling a dice in this situation, does every possible roll of a dice have an impact? Do I do something with every possible roll of a dice? A paradigm.
Well, we don't have anything for odds that aren't 7.
So therefore, I don't give a rip about them. My problem didn't tell me to do anything with them. So therefore, there are stuff data, potential output or input that I don't want to deal with. So there's a real good chance, if not 100% chance, that I'm not going to have an else here for the big picture. Okay? Therefore, this else, because there would be nothing going down to C. We would never hit C. If we did this code, it would never hit C. If it was even, we're going to do whatever we're going to do here at B. And if it was a 7, and I don't give a rip what happened when it got down to C. So how do I, and this comes back to the question, what do I do if it isn't even? Inside of that, now that I know it's even, my next bite of banana said, if it is even, then if it was less than, it was 2 through 6, I do something, or if it was above that, I do something. Everybody see that? So what construct do I use then? I now know it is even. What construct do I use? We are now in here. We know that. Am I doing something, or the questions we ask, and this is what, even you guys, this is kind of cool, because where you are is exactly where your students would be, isn't it? You're running through with all these possibilities in your head, and that's because we have not strengthened and built the algorithm really well yet. And what was the question I said to ask? Are we going to do something with everything? If we know it's an even, are we going to do something with everything?
Yes.
Yes. Therefore, what tool do I pick up? Because is there only one option, or there's multiple options? That's why we're taking this choice in the first place. What tool do I pick up if I'm going to do something with everything?
Can you give an example of what you're trying to do with the 2, 4, 6, 8, 10, 12?
I'm just going to tell me how many there are. I'm playing a game that has, you get special rewards, or you earn, it's like a Pathfinder field bet. So if you get a 2, 4, 6, so if you get a 7, you lose $100. If you get a 2, 4, 6, or 8, you win $20. If you get 8, 10, 12, you win $150. There we go.
Then why don't you nest an if else within your elif?
What do you, why don't I? That's exactly what I do, but why? Why do I know I pick up an if else tool? You're exactly right. That is the answer. And we all, those who know coding and have done this before, you knew that answer. But guess what? If you look around your picture, there's 1 or 2 other faces there that are even willing to have the guts to show their faces that don't really see which tool to pick up. And they're smart adults. And so therefore, we have to give them a tool that says, aha, what questions do I ask myself to know what tool I pick up? And in this case, since I know it's even, that's why I put a box here. I know what we're doing here. What tool do I pick up since I know I'm going to do something with every even value? And that is I pick up the if else. Why? Because the else traps everything, right? We just said we're going to use everything. So the question is, in this subset, wherever I am, when I'm solving this little piece of the puzzle, do I do everything? If the answer is yes, every possible thing that's in here, I'm going to do something with it. Then I use an if else. If there are some pieces that I don't give a rip about, I'm not going to do anything with them, then I pick up a different tool, an if, or a series of ifs, if that's what's necessary. Do you see what I'm trying to get across here?
Yes.
Somehow
Yes.
you've got to get that into your kid's head. We have to teach it so that they understand that. that there's a reason for it. So yeah, what we have, we had if, and we'll talk about this, else. And how did we separate this? What could we do for answers here? Or 2, 4, 6, or 8. They did this 8, 10, 10, 12, 2, 4, or 6. We did something. 8, 10, 12. We did something else.
Yeah, if it's less than or equal to 6, count less than 6. Else, count more than 8.
And did we need an else if, elif on the second one?
No, because else is everything that's not
Yeah.
the first if state.
As a matter of fact, if I can set that up to do it that way, the computer thinks less, I do less. It's a win-win all over the place, right? I don't have to have an LF, we're cool. I do less work, so does the computer. I like that. Does everybody see these? So notice, the question was, Johnny asked me to explain how do I delineate between if else, and so forth. I have to come up now. One is, when in my subset, whatever I'm checking here for value, does every possibility have to be touched? Do I have to do something with every possibility? If it's grades I'm inputting, does every grade have to be impacted in some way, shape, or form, added up, calculated? I don't care. Rolling a dice, does every possible roll have to do something? If that's the case, then I have an if then else sequence. If there's some left out, I don't. And we will have an if because I don't want to deal with the other stuff. That's the number one question I think kids need to learn to ask themselves. Okay? Does that make sense, guys? Or we get 2 minutes or 1 minute. Oh, shoot. You know what? I have 95 notes here. Oh, she did. Thank you, Kathy. I didn't hit record way back when. I don't know when she started.
What did I do? What did I do?
Did you hit record or something? You
Yes,
must have
I
started. Thank you. I have red notes everywhere. I have them all over the place. Record. And I just realized this second as I looked out and saw record that I didn't do that.
Always
So,
have
real
your
good.
back, Kirkwood. No worries.
Michael, you need to smack me. You're not doing your job. You're not keeping me under control, Mike. Come on. Jeez. So, what I would recommend this week is you look over stuff and think about stuff and send me questions relative. The question was asked, how do I delineate between looping structures? We kind of have that, I hope, and there's an algorithm. The other question was asked me, how do we deal with if-then sequencing? And did you need to build a tool? Because it is not natural for everybody just to do it, right? To see it. We need to figure out a way to explain it. Now, maybe the way I did, especially since we're rushing, and I really should have started slower. I apologize for that because I'm trying to get further, but that's not effective always. So I will slow down potentially the last week. We'll see what's going on. I apologize for that. Please stop me as many of you did. But if we're doing this, we need to delineate and create an algorithm for the kids to attack to it, okay? Next week, we will, if you'll look at the outline, we will deal with some of the algorithms and stuff, and we'll talk about the code. What I would recommend highly, if you look at those code sheets, to skim through them and go, oh, Lordy, I don't know, how would we even do this one? That would be fantastic, because then what we can do, what I think might be most effective, rather than going on into lists or other things, even functions, would be to look at these things and say, now that we got these algorithms, let's actually practice them. Let's sit down and look at a problem and say, I got this problem. How would I attack this problem using the tools that we supposedly have? Because then you do the same thing that kids are doing. I think that might be most effective. If you've got other ideas, please kick them to me and I will attempt to incorporate those in the puzzle.
Now, Don, am I missing a document? Because I have the intermediate code listing P1, and that has like different descriptions of things like compound interest and factorial and quadratic formula. And I also have the if and elif document, but you said there was a list of problems?
Yes.
Is there a document with a...
There's a thing called compilation of code problems. It's
Got
like
it.
12 or 15 pages. I don't know where it was. But compilation of code problems is the one, if I was you, I would just kind of really, whatever time you got, skim through that and either pick out a couple problems to play with or what might be really ideal is pick out several, and we can use those in class to go through and use our attack plans to say, is this an effective way to attack these problems? There's a wide variety of stuff in here that, and if you've got other stuff, Michael, you may have some stuff still left from old days. Anybody else has other problems that you think are cool, please kick them to me and we'll just add them to this big list.
Perfect. Thank you for that clarification.
Good, no problem. Yeah, there's stuff, and people ask me to put it in a zip file, and I'm going, so I try to organize it. There's code, and then there's documents, and then there's documents, there's lists of stuff. So I kind of have separated it that way. And the Kathy has put the chat stuff in there, and I put that, I think, as a separate folder under documents. Yeah.
Don, did you include I haven't seen it. Did you include the pass line field game?
No, I don't have that in there specifically. I've alluded to that several times. I haven't put the rules in and stuff like that. So Michael, as a matter of fact, I couldn't find that specifically. If you got one of those, easily pop it over to me, because that's kind of a real cool one.
Okay, yeah, that's a really fun one for the kids, yeah.
Yeah.
Now, do you want us to keep emailing you and annoying you, Don, or would you, with stuff we come up with?
You never annoy me, of course not. I can completely ignore you. So, no, yes.
My job.
That would be helpful, actually, because knowing what, in this case, I'm paid the big bucks. I think, yeah. No, I like Kathy smiling. That's really appropriate, especially now. But I do get paid more than her, which says something, that she does a lot more work than me. But anyway, not much, a little bit. But the fact comes to be, yes, my job, what I want to do for this last week especially, is meet whatever needs you guys have. And so, yes, please annoy me as you will.
Okay, thanks.
Yep.